Hi and welcome to Geeks for Geeks. Today we would be doing the post contest analysis of GFG Weekly Coding Contest. So let's talk about the feedback from my side and then you can talk about the feedback from your side. So many people were able to do all the three problems. Like even after just after the contest itself, I received a lot of DMs in my LinkedIn that yes, Bhaiya, I was able to solve all the three problems. So this contest was kind of very easy. The very next thing is that not very easy, but the problems were a variation of the very standard one. To be honest, not just a variation, like a direct problems of a very standard ones. Okay, hi Anshul, how are you? So, how many problems were you able to solve on your end? Let me just see. hmm Okay, only one. Okay, fair enough. We would talk about how to solve all this kind of problems. So I think we are good to move forward. I sir jump to solution. I can't jump to solution basically. Okay, so I think I'm good to go. Need to change the screen orientation to this, and we are done. So let's talk about the very first problem itself. So the very first problem I can call it that do as said. Okay. So now let's see this problem first. Okay. So it is said that there is a conveyor belt of size this. Okay. So there is a conveyor belt of 1, 2, and 3. And it is said that if a new element pops up, like suppose a new element is coming up, and I have not seen that element, okay, then I would do 1 unit of work. Okay. If I have already seen that element, I would just ignore that element. Okay. If the conveyor belt is filled, okay, like we have all the three elements residing at this conveyor belt and a new element is coming up, then we need to remove the very first element that has popped in. Okay, translating the same in Hindi would be that एक conveyor belt है, okay, जिसमें तीन items रहेंगे. Okay, so suppose let's say तीन items ही as of now, let's say conveyor belt में तीन ही items रहेंगे. So अगर 1 2 3 है सोचो और फिर से नया 3 आया, 3 तो पहले से हमारे पास है. अगर कोई न्यू एलिमेंट आता है जो पहले से हमारे पास है, सो क्या होगा कि हम लोग ये बोलेंगे कि बस इग्नोर करो. अगर कोई न्यू एलिमेंट आता है जो पहला बार हम लोग उसको पहली ही बार देख रहे हैं, तो हम लोग एक यूनिट ऑफ वर्क करेंगे और उसको लास्ट में आके रख देंगे. बट लास्ट में आके रख देंगे दैट इज फाइन. बट अगर क्या होगा अगर कन्वेयर बेल्ट पहले से फिल्ड हो, सो व्हाट वी नीड टू डू इज द वेरी जो सबसे पहले आया था उसको निकालना है और नया एलिमेंट डालना है. ओके, सो नाउ व्हाट आर द स्टेप्स वी नीड टू डू. Okay, in this problem, so let us first see this sample test case. Suppose we are given one, the conveyor belt is empty. We have not seen up one up till now, so we would keep one, and the work done at this point is now one. Earlier it was zero, like we started from the work done as zero. Then we saw a new element that is 2. 2 has not been sealed, so I would update the work done by 1, and then I would keep a new element that is 2. Then we have the third element and we have not seen 3. So we would update the work done and we would keep this element itself. Okay. Now, after that we see 1 again and we have already one, so we would simply ignore that. Now we have 4, that is a new element we have not seen up till now. So now we need to remove a element. So now we need to remove the very first element which was there, like the oldest element which was inserted in the conveyor belt. Oldest element was 1, so we need to remove this one. We need to remove this one, and then we need to shift up this conveyor belt. So I can't shift up, I would just write 2 and 3 here, and here comes the value of 4, and we have did 1 unit of work, that is added a new element, so the answer is 4. That is why this is. So am I clear with the problem statement? Am I clear with the sample test case? Give me a quick one. So give me a quick one if I'm clear with the sample test case and I'm clear with the problem statement itself. Okay, I'm clear. What about others? Okay, so quickly like the video. What is the number of likes of this video? Let me just see quickly. GFG practice. Quickly. The number of likes are only 15 at the moment. Quickly like the video and make it go above 60. Okay, fair enough. This is done. So now what are the things we need to do? So the things we need to do in our program is to implement this program as it is. Like whatever is told, suppose we want to implement this. To implement this program as it is, we need to first have the conveyor belt first. And then we need to check if that element is already present or not. So we need to remember the element. So if we want to remember element, like we need to remember element that we have already seen it or not. Like suppose whenever we see a new element, we first need to check on our database that it is already existing or not. So remembering. So remembering means we have hash map, we have map, and we have set and all this. Okay, set, multi-set and all this. So the very first one is, you can take either of this, but I would be simply using a set because I need to write less. That is why. Just you can use it map also. Okay, so I just need to remember. So either of the way it is fine. So remembering part is done. Now the part is that after suppose that element is not present, so we would insert that element, and if there is a space. What is the scenario when there is no space? So we need to remove the oldest element. Okay, so what we need to do is we need to follow a ordering of first in, first out, first in, first out. So we need a data structure to store element where the elements would be stored and popped out in this fashion. Like whatever element is coming first, it would be popped out first. So the answer to this is basically the idea known as queue data structure. Okay, like even if you see first come first serve basis. So let's say in a stall, you went to eat in a stall of, and there are n people standing up before you, so they would be served first. So that is a queue that you are standing. So basically you would use a queue data structure and you would use a set data structure to do it. So now I would start the implementation, but before the implementation, let me just give you a pseudo code. So basically what we would do is we would use initialize a set. Okay, we would initialize a set as well as a queue itself. Okay, and then what we would do is, suppose we saw a new element. Okay, we saw a new element. So if new element is there, we would check if it is existing or not. We would first check if it exists or not in our database. Now there are two conditions. The first one is yes, it exists. The very next one is no, it does not exist. Okay, so no, it does not exist, or yes, it exists. So if it does not exist, like yes, if it is existing, Like, let us write it here. If it exists, then we would simply ignore. We would simply ignore. If it does not exist, now there are two conditions. If Q has some space left. If there is some space left in the conveyor belt, and how we would know it? We would know it by the size of the queue. So if size of the queue is less than the given conveyor belt size, then we would simply insert. And if this is not the condition, what we would do is we would remove from the queue and then insert. So am I clear with the pseudo code or not? Give me a quick one. Just give me a quick one if I'm clear with the pseudo code and all. So now we would start with the implementation itself. I would do a sharing of tab, calculate the work done. Okay, this is the conveyor belt size, and we would just represent it with a value of m. And now we would start the coding part. So we would initialize a queue of integer and a set of st, like let's say st set, and the work done, the answer up till now, work done initially is 0. This is the answer, work done. So now we would start the iteration for auto e of a itself. Okay, or let's not take a for each loop, many people would be confused. Let's take a simple loop itself. Okay, so now we would first see if that element already exists or not. So st if st dot find a of I is not equal to st dot end. So basically this just tells us that element is already present. Okay, this is the syntax of stl of set. If you are confused with this, just kindly learn about set. Okay, this just tells us that the element is already present. If the element is already present, we won't do anything. We would simply continue, like we would simply ignore. Okay, we would simply ignore at this point. Now if that element is not present, okay, we need to do one unit of work first, whatever be the condition, and then we would push the new element, that is a of I. Okay, now after pushing, if the size becomes q dot size becomes greater than the conveyor belt size, we need to remove that element. So q dot pop. But before popping, we need to remove that from the map also, like set also. So st dot erase q dot front. Okay, and then we would pop it. After all this, we would insert. Okay, q q dot st dot insert a of I. Okay, and then we need to return the answer. So now you can simply remove this if condition also. What you can instead do is, like this was just to show you, we can say if st dot find a of I is equal to st dot end. If this is the condition, then we would do this. And we can simply remove this. Okay, like if element is not present. Element is not present. Like, see, you can write if the element is present also for that condition, but writing a vague if statement is not providing us. Like, if the element is already present, we don't need to do anything. So why to write a condition for that? So we would only do something when that element is not present. Okay. Now just compile and run and see how many errors are we making. Okay. It's done. Now tell me the line number at which you are not able to understand, and then I would move forward to the idea. So quickly tell me, what is the need of having and why can't we find the element in DQ itself? So see, finding the element in an array of unsorted is linear search. Linear search has a time complexity of log n. Sorry, linear search has a time complexity of big O of n. We can't use binary search because binary search needs a sorted array. So now we need to use some data structure so that we just remember if that element is already present or not. Line number 39. This is the syntax of STL. This is the syntax of STL of set. If you are not able to do this, set in C++, kindly learn about iterators, set and all this. You need to learn this. Okay. For those who are not able to understand line number 39, you need to learn about iterators. What is iterator? What is finding an element? What is STL? So basically, this just tells us that the element is not present. This just tells us this. This if statement is just this. This just tells us that the element is not present. We can simply use a hash map if the frequency is 0. This is just telling us that the frequency of this element is 0. This if statement is telling us this. I was using a queue though. They will be using set and unordered set. See, don't try to avoid unordered set in online judges. Why? Because unordered set has a time complexity, watch time complexity of big O of n square. Okay, that is why. That means that the element is not present. Element does not exist. I have written that as a comment also. Any more further questions you have? Okay, so I think we are good to go. Can we use frequency array? Yes, absolutely. You can use frequency array because the size of the array is 10 to the power 4. So you can use a frequency array. Like what you can do is you can simply have a vector of int of f of size 1e4 plus 5 comma 0. Okay, and then you can simply say, let's, many people are not able to understand this, so let's do it. F of a of I, f of a of I, if it is equal to 0, then we would do something, and this one would be f of a of I minus minus f of st dot front, sorry, f of q dot front element, and then f of a of I plus plus. Let me just see it again. F of a of I is equals to 0. Answer q dot push a of I if it is greater. But it might be a scenario that I might get a TLE. Why? Because internally it might be a scenario that they are using a lot of test cases. Internally they might use some test cases. Okay, they are not using any test case. Thank God I'm saved. So if they were using test cases in the backend, that means we are creating a 1e4 size again and again. So we would use a TL, get a TLE. So now is this thing code clear? Yeah, we can use another thing. We can do what is the point of storing it? If we use another thing, we get duplicate. What's the point of storing it? It's done. Basically, people avoid using ARR of I, because see here in an online judge, see here online judge is like solving problems over competitive programming. Okay, so the main idea, like the main difference between solving a problem in an online judge and solving a problem, like let me just tell you. Okay, so see the main problem, like main idea of solving a problem over an online judge and solving a problem in an interview. The main difference is that our whole focus is to just surpass the time limit. Okay, like मुझे किसी भी तरीके, like see we are given a time limit of 1 second. So if we use, okay, so like suppose we are told that you just need to do it in 1 hour. So if we use 1 minute, if you use 55 minutes, that don't make a difference in an online judge. So we don't aim for the most efficient solution, rather we aim for a faster solution, like which we can think fast, which we can implement fast, and we can get an AC with that also. Okay. Yes, in an online judge, we don't focus on code quality. Okay. Our main focus is not just to aim over the best solution or the best aimed solution. Our main focus is to just surpass the time limit. Okay. So I think I'm good to go. Let's move forward to the next question. Make an array beautiful. So this question, now I would require less problems again. Okay, see. So in this problem, what you can do is you need to make this array beautiful. An array is beautiful if every element is divisible by 3 itself. And you need to find the minimum number of operation. What is the operation? You can take two elements, append their sum, and you can rewrite it. Okay, this is what is given. And if you can't do it, write -1. So translating the same in Hindi would be, एक array दिया गया है, उसको उसको beautiful है, like एक array दिया है जिसके सारे elements को divisible by 3 बनाना है. और कैसे करके बनाना है? सो ऑपरेशन ये है कि आप कोई भी दो एलिमेंट उठाओ, उसका सम करो और सम array में फिर से डाल दो. Okay, and at the end, which if every element is equal divisible by 3, we say it is beautiful. If it is not, then we return -1. Okay, so now how we are getting the output as 4 itself. Okay, so the output is 4 by doing this. So first we are adding 1 and 4, that makes it. So let's just do it in the array, like let's write in big array and let's edit this here itself. Okay, so what we are first doing is we are first adding 1 and 4 and we are inserting 5 here. So one operation is done, and then we are adding 5 and 7 and we are writing 12 here. So second operation is done. Then what we have is then we are removing 13 and 5 and we are writing 18 here. And then obviously we are removing 10, and that is we just did an operation, that is 3. And now we are removing 10 and 2 and we are writing 12 here, and the number of operation is 4. So the number of operation done is 4 to make all the elements divisible by 3 itself. So do I make sense? Like what is the sample test case? how the value 4 is coming up, what we need to do. First, tell me if these things are clear to you or not. Quickly tell me. Give me a quick one if things are clear to you. Else give me a zero that sir, this is the thing that I'm not able to understand. But don't call me sir. Okay. Jaidev Kundu, can you quickly tell me the point at which you are not able to understand? By the way, what is the number of? So I would be waiting for Jaidev Kundu a bit for 1 minute, I suppose. Tell me the point at which you are not able to understand. And you can unmute yourself too, if there is an option. So number of likes are 40 and the number of live viewers are greater than 50. Okay, so I think Jaideep Kundu is not at this point in the stream. So I would consider moving forward. So let's move forward. So now, what we are basically doing. So numbers which are divisible by 3. So let us first write the numbers which are divisible by 3. So divisible by 3 would be the multiples of 3. 3 is divisible by 3, 6 is divisible by 3, 9 is divisible by 3, 12 is divisible by 3, 18 is divisible by 3, and 21 is divisible by 3. Okay. Now, which numbers are not divisible by 3? So numbers which are not divisible by 3 are 3, then 4, then 5, 6 is divisible, then 7, then 8, and then 9 is divisible, then we have 10, and then we have 11. So we saw that these numbers are not divisible and these numbers are divisible. Okay, so now let us analyze that what is the issue here. So divisible means that this number modulo 3 is equals to 0 and this number modulo 3 is not equal to 0. This just means this. So now we can say that let's write the modulo only. So 4 modulo 3 is equals to 1. 5 modulo 3 is equals to 2. 7 modulo 3 is equals to 1. 8 modulo 3 is equals to 2. 9 modulo 3 is equals to 1. Then 11 modulo 3 is equals to 2. And these all are 0. Okay. So now let's see. Okay. So suppose this 4 has, if we decrease 4 by 1, then the modulo would be 0. अगर हम लोग 4 से एक 1 कम कर देंगे इसका मतलब वो मॉड्यूलो 0 हो जाएगा क्योंकि यही एक्स्ट्रा है. So this is the overflow in the modulo that is causing all the problem. So now I can say that 4, if we add 2 in 4, then the modulo would become 0, and if we add 1 in 5, then the modulo would become 0. Like suppose if we just write 4 and 5. Okay, 4 modulo 3 is equals to 1, 5 modulo 3 is equals to 2. So if we add here 2 in this part, then things would be modulo 3 would become 0, and if we add 1 in this, then the modulo would become 0. Like 4 added to 2 would make it modulo 0, and 5 added to 1 would make it modulo 0. Okay, so this requires 2, this requires 1. So what I can do is all the numbers which have modulo 3 is equals to 1 and all the numbers which have modulo 3 equals to 2, I can pair them up and they both would become modulo 3 equals to 0. I can do this. Okay. So now what are the modulo values? So I can have modulo 3, I can have 0, 1 and 2. So 1 and 2 would be catered with this. Let's talk about the scenario where we have more than, like where we have just one. So if we have just one, so if we have three numbers, modulo 3 equals to 1, modulo 3 equals to 1, modulo 3 equals to 1, or 3x number, then we can just sum up three values and modulo 3 would now be equal to 0. Okay. And if we have two values, okay, like suppose we have modulo 3 is equals to 2, modulo 3 is equals to 2, and modulo 3 equals to 2, then I can sum up all these value, and now the modulo 3 would be equal to 0. It's done. So now I just need to make a pairing of 1 and 2. So 1 and 2 would be extracted. They would make one pair. And then three values would make another pair. And last one would make another pair. So I would first find all the modulo values. Okay, I would first find all the modulo values. Okay, and then I would start pairing them up. So let us first find the modulo values, and then we would talk about the pairing part, how we are pairing and all this. Okay, so first, see, all the numbers which have modulo 3 equals to 0, we don't need to touch them. Okay, so we would only cater count of 1 and count of 2, because count, if it count is equal, that modulo value is 0, then it is already divisible by 3. We don't need to touch it. So all the numbers which are not divisible by 3, we need to process that once. जो भी नंबर 3 से डिविजिबल नहीं है, हमें उन्हें प्रोसेस करना है, तो हम लोग सिर्फ उन्हीं पे फोकस करेंगे. So now we would start with the iteration. For int I is equals to 0, I is less than n, and I plus plus. At this point, we would say if a or I modulo 3, if it is equal to 1, then I would say C11. First, we would count this. Okay. And then we would say else if a of I modulo 2, modulo 3 is equals to 2, then we would say C2 plus plus. Okay. Now I would say that all the 1 and 2, okay, 1 and 2 would make pairs. So I would say that suppose the number of 1 is 3 and the number of 2 is 2. So then I can make two pairs only, like suppose there are 3 2 and only 2 1. So I can just make a pair of this. So what I would say is, I would say minimum of 3 and 2. Minimum of 1 and 2. Minimum of 1 and 2. So I would say diff is equals to minimum of C1 comma C2. And these are the values that I would remove. So I would say that int answer is equals to diff. Okay. Now I would remove this from the value. Like these elements are now done. Okay. So C1 minus is equals to diff, and C2 minus is equals to diff. First, we would remove all these pairs. Now let's talk about the scenario when we have just, so 1 and 2 is now handled. 1 and 2 is now handled. Let's talk about the scenario when we have 1 1 1 like this. So if we have 1 1 1, then they need to be either 3 or 6 or 9 or 12. Like they need to appear on a set of 3. It can be 3 also, it can be 6 also, it can be 9 also. But if number of ones are just 4, then one would be extra and we won't be able to make it. And number of 2 goes also the same. So we would say if C1 modulo 3 is not equal to 0, or C2 modulo 3 is not equal to 0, then we would return -1 from this point. Like we can't do it basically. Okay, if it appears in a set of 3, we can do it, else we can't do it. Okay, now comes the scenario Like suppose there are nine twos. So nine twos means, so suppose there are two twos. So what we would do? Suppose this is 2, 2, 2. So what we would do is we would add in one operation, we would add 2, 2. So that would become 4. That is one operation. And then we would again add 1. That is 2 operation. So if we have a set of 3, we would require 2 operation. Okay. So divide by 3. So I can say the formula is number of twos, number of twos divide by 3 multiplied by 2, because 3 twos require 2 operation. 3 twos require 2 operation. So I would divide 3 multiplied by 2. Same goes for 1 also. So I would say return answer plus C1 divided by 3 multiplied by 2, and then we would add it with C2 divided by 3 multiplied it with 2. Compile and run and see how many errors are we making. Seems like no errors is being made. So the output, my code output should be -1 C1 modulo 3, this would be. Yep, it's done. So I just told 3, but I mistakenly typed 2. Okay. So now am I clear with the solution? Tell me the point at which you were not able to understand. Make the array beautiful. Okay. Sir, can you explain the problem on one more test case? Which problem? This one, just Harjaspreet Singh. Quickly tell me this problem. Give brief recap. So it's better that you just shift back to the time and you watch the stream in a lagged time, so that the time frame of more than 50 students would be saved. Sir, solve the question using binary search. Got it clearly. What might be the correct and optimized approach for the third problem? Last problem is binary search only. Line number 46. Okay. Line number 46, modulo 3. Done, sir, done. Thank you so much. Last value is binary search only. I think you have you have misplaced some part of the code. Sir, please, line number 46. Okay. So now see. Suppose we have, am I sharing the screen? Okay. So line number 46. So now suppose that we have 1, 1, 1. If we have 1 3 times, then we can simply add up all the ones together and we would get a value 3, and the array would be beautiful. If we have 4 ones, then we would add up all this 3 and we would get 3, but this 1 can't be resolved. So we can't do it. Okay. If the number of 1 is 5, then we again can sum up all this and make a value 3, but we can't solve this problem. So we don't do it. And if the number of 1 is again 6, then that 3 can sum up to 3 and this 3 values can sum up to 3. Okay. So we need ones in the multiple of 3. Okay. That is why, and same goes for 2 also. Like if we have 2, 2, 2, then we can solve it by 2 plus 2 4, 4 plus 2 is equal to 6. But if we have 2 4 times, then we can't solve it. Why? 6 comma 2, you can't solve it. And if we have 5 twos, then you can't solve it still. Okay, so you can't solve it. Okay, that is why the answer to this is minus 1 itself. Okay, that is why if C1 or C2, if they are not appearing in the value of 3, we are not doing it. And now see, C1 divided by 3 multiplied by 2. Many people were asking last line. So let me just first highlight it. Last line. Yep. So see, the thing is that suppose I have 1, 1, 1. Then the very first operation I would be doing is I would add these two values, I would get 2. So I have used one operation. And then I would add these two values also and I would get 3. So this is the second operation. So for every 3 element, I would require 2 operations. So total number of operation would be divided by 3 and multiply it with 2. Because for every 3 elements of 1 and 2, we require 2 operations. Now am I clear? To be honest, you don't need the screen. Okay, now suppose I'm just explaining this. 1 1 1. So the very first operation we would be doing is we would add last two elements. Okay, this is the very first operation and the resultant value would be 1 comma 2. And then you would be adding these two elements and the number of operation would be this and the value would be 3. Now that is beautiful. So I can say that for every 3 elements I require 2 operation. Okay, so I can say that divide by 3, multiply it with 2. This is what I'm doing. So now am I clear till this point? Line number 47. Yep, it's done. So Sarthak Chaudhary, am I clear? Sir, your code is very neat and clean. Mm, Actually, this is not the code I write. Basically, if you ask me, like, if I were to write this code in reality, what I would have done is instead of finding out this min and all, I would have directly did this here itself. I would have used a for each loop at this point, for auto e of a. But people that like that won't be intuitive for people of very beginner level. That is why I write code in this very beginner friendly format. Otherwise, the way of writing code for me is a little bit difficult. No, my code is not redundant. It is always clean, I can say. But I try to write as less as possible. Like the implementation time should be as small as possible. I think so. For me, this is the main aim. And I try to make the problem as generic as possible. Most welcome. So for all the people for whom I have explained the problem explicitly, I need a comment from you all. Okay. So now this problem is a very standard problem. Okay. Like the same problem I have seen somewhere else also. Okay. Like the same kind of problem, only the subject is changed. So this is a very standard problem. So basically you are given an array of size n and you are given the quality of the ith type of chocolate. Okay. Now you need to distribute the chocolate among m number of students. Okay. And each person should get exactly the same number of chocolate. And you need to find that the maximum number. Just there are two things that needs to be respected. The very first one is cannot get more than one type of chocolate. One person can't get more than one type of chocolate, and every person should get same amount of chocolate. Okay, this is what is to be done, and now you need to distribute it. So now we have one, we have two, and we have two. So there are five students. So suppose this is the one, this is two, this is three, this is four, and this is five. So first you give up this chocolate to this person, and then you give up this chocolate to this person, and the remaining one chocolate to this person, and the remaining two chocolate at this person. So see, you don't need to exhaust all the chocolate, but the main aim should be that everyone should get the same amount of chocolate, and no person should get more than one type of chocolate. Okay, like it can't be the scenario that you are gifting two chocolates to a single person. One chocolate you are taking it from here, and one chocolate you are taking it from somewhere else. Okay, so if you are gifting someone a chocolate, that chocolate should come from a particular element only. Okay, this is what I am talking about. Fair enough. So now the idea is very easy to understand. So basically, we need to gift him the maximum number of chocolate. So if we are told the maximum number of chocolate, what we can do is we can first try to give one chocolate to everyone. If that is possible, suppose suppose the maximum number of chocolate is 4. Okay. So what we can do is we can first try to gift everyone one chocolate. Then we can try to gift everyone two chocolates, then three chocolates, then four, and then five, then six. And then we would find out that this is not possible. This is also not possible. This is also not possible. And all this was possible, and we need to find this point. So this is a kind of this kind of thing. Like first it would be yes, 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 and then it would be no, 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 no. And you need to find the last point where it is yes. So every time you need to do this only. Like suppose the answer is 5, so the yes would be till this point, and you need to find the answer 5. Why? Because you need to find the maximum number of chocolate that can be given to a single person. Okay, this is what you need to do. So maximum number of chocolate is y only, and you need to gift this person. Okay. Okay. Fair enough. Yep. So now, basically, whenever you see this kind of thing, this is a monotonous function. Okay, this is a monotonous space. Function, space, anything you say. Okay, and you need to do a binary search over here. Okay, so what you need to do is you need to assign the low as the lowest element and high as the highest element. And if it is possible, like see, if it is possible to have an answer, like suppose if mid value, we checked for the mid value. If it is possible, like if the answer to that value is yes, then suppose we are checking on this element, and if it is yes, then we need to make L go to mid plus 1. Like suppose the mid is pointing here, let's say the mid is pointing at 2, and the value to that is yes. So at the next iteration, what we need to do is we need to make this L go at this point. So if it is yes, then low is equal to mid plus 1. If the value is no, if the value is no, let's say if suppose mid is pointing here and we got a no value, then what we need to do is we need to take up this high and we need to write it here. So what we need to say is high is equal to mid minus 1. Okay, so just remember this thing and you are good to go. Okay, this is what you need to do. Yep. So I would start the iteration. So the maximum amount of chocolate that you can give to a particular person is the maximum element. Okay, this is what is there. So I'm sharing the whole screen. No, I don't want to share the whole screen. I want to share just the Chrome tab, distribute chocolate. So what we need to do is I would just make this as a itself. Okay, and then I would initialize low number of chocolates that we can give. Lowest is this one and high is equals to, see, there are two options you can do. Either you can take up the highest given element, or either like you can just take up this. Okay, 10 to the power 9, so we can just take up 1e9. Okay, and we are good to go with the binary search. Okay, but let's take a very large value. Okay, while low is less than equal to high, this is the code of binary search, and we would first find out the mid element, and we would say low plus high divided by 2. Okay, so if the answer is yes, if the answer to this is a yes, if the answer to this is yes, what we need to do? Okay, so I shouldn't share my screen. I should share the whole screen now. If the answer is yes, okay, if the answer is yes, then we need to do low is equals to mid plus 1. If the answer is yes, then low is equals to mid plus 1, and we would just save the answer. Answer is equals to mid. If the answer is a no, if the answer is a no, then what we need to do is mid minus 1, and we don't want to save the mid. Okay, if the answer is equals to, then high is equals to mid minus 1. Okay, high is equals to mid minus 1. At the end, we just need to return the answer. Okay, now let us just draw design a check function. So check function where we would be getting the value of vector int passed by reference a and the value of mid itself. Okay, now what we would do is int c is equals to 0, and here we would also pass the value of int m. Okay, now we would say we would iterate over the array itself, and we would say c plus is equals to e divided by the value of mid. Okay, if c is greater than equal to m, okay, like if we can give chocolates more than m elements, then it is fine. We would return a true value. Okay, else we would return a false value. Okay, good enough. And here we would say, like, what is the name? ck, check of vector a comma mid comma m. Okay, now let us see if we are getting on a correct track or not. Sorry about that. Now let's see. Okay, we are getting correct answer. But if we submit this, this would also give you an AC. This should give you an AC. This should give you an AC. But there are some optimization that is left. The small optimizations are, so first tell me if this solution is clear or not. Then I would do small optimization that you can do as an intermediate programmer. So if you are doing advanced binary search or binary search on an answer, okay, if you are doing binary search on an answer for the very first time, then take a very large value as the value of high. But if you are not a person who is doing binary search for the very first time, I would show you that also. Type bool check function return true. No, see, I can just return 1 and 0 and it would be treated as the same. 0 means false, 1 means true. Can you explain again the check function quickly? Yes, absolutely, I can explain. That is my job only. Okay, see what we are doing is, we see this mid is telling me that I need to gift each person two chocolates. Let's say I need to give each person two chocolate. So if the value of E is equals to 4, that means I can give two person. How I can say that? 4 divided by that person. That means I can gift two people two chocolates. So I am just counting the number of people I can gift two chocolates. So if the number of people I can give two chocolate is more than the number of people that is told, that is good enough. But if it is less, then it is not good. Okay, greater than equal to. So it's just that suppose mid is equals. Suppose we are told that distribute two chocos. Okay, two chocos. So how I can say? Okay, I can say that I suppose suppose I have five chocolates. So I can distribute two chocolates to how many people? 5 divided by 2. So in the same manner, this mid, I'm just dividing it and then I'm adding it to the value of C. And after that, I am just checking how many people I can give. Am I clear to you, Raja Gupta? Give me a quick yes or no. So now there are some small optimization that you need to do, that you can do. So very first optimization would be that I can say, instead of this, I can say return C is greater than M. If C is greater than M, it would return 1, else it would return 0. And now comes the position where you don't want to take, in every binary search, you don't want to take a very high value. So now the optimization would be that you initialize with it with 0 and you take out the maximum element. For auto E dash the array A and high is equals to max of high and E. Okay, and this one would be a more optimized one. Okay, now let us just compile and see how many errors are we making. Okay, now the last person, someone was asking me that your code is very neat. So this is how I would have written the code if I was in an online judge. Okay, this code is concise, this code is very up to the mark, and this code is the most optimized. I think so. So E is the value in the array. Yes, E is the value in the array. While low is less than high and low is less than equal to high, difference. So that is the two kind of implementation that is used for binary search. Some people have a different way of using binary search, some people have a different way of binary search. Okay, so see, the thing is that I have been using this implementation less than equal to high for the past 3 years, and I have never got a TLE or something. So I'm very used to this. Low is less than high is used by many people also, but this is my implementation of binary search. There are many implementation of binary search, and you can use mine if don't have. Else you can move forward with that also. Okay. So E is the value in the array. Yes, absolutely, by using a for each loop. Sir, is there a common pattern for solving problems that make array beautiful? Yes, absolutely. Like, see, suppose you want to make all the elements divisible by 3. So divisibility is kind of very related to modulo. So you need to observe what is the modulo. Okay, so even if you had observed the sample test case, then you would have seen that why we are merging this two, why not that two. So if you have a question like this, हम इन दोनों को ही merge क्यों कर रहे हैं, इन दोनों में ऐसा क्या common है? अगर आप इन दोनों का modulo देखते तो you would have got the hint that I need to use a modulo thing. Okay, so basically you need to analyze the problem. Okay, D cool, am I clear to you? So am I clear to everyone? Give me a quick one for the last time and I would be turning on this session. I don't think there is much issue to this. Okay, thank you. So I would be waiting for the next 30 seconds. You can ask me anything you want and then I would be turning on this session if I don't get any queries for the next 30 seconds. So now I need to quickly check over this because many a times it happens that I receive here the comments late. You are most welcome. What is the intuition behind the distribute chocolate problem? So distribute chocolate problem. One question, one reason, three question. Okay, distribute chocolate problem. What you can do is that is very easy to guess. I think so. That I saw a function that I need to find the maximum value which is true. That means I need to find the last occurrence of y in a monotonous function. Monotonous function is equals to binary search, and we just solve it. Okay, when to change low and high. Change low and high when you have a lot of test cases. Else move forward with high is equals to a very large value. You're most welcome. So that's it for today. If you want this legacy to move forward, and if you appreciate this kind of contribution to the community, like having a free coding contest where registration is free and watching the post contest analysis officially where it is also free, so you can promote it by simply liking and commenting on the video. So that's it for today. Thank you and have a nice day. This is me, Siddharth Hazra, signing off. Thank you.